Okay, so moving on with example 5, it says use the graph of f of x equals x squared to obtain the graph of g of x equals 1/2 x squared. Alright, so I know that x squared is my parent function, so I'm going to do its table. And so for x squared, remember we use the numbers from -2 to +2. And then we just squared them, so -2 squared, -1 squared, 0, oops, -1 squared, 0 squared, 1 squared, and 2 squared. Alright, so for our function here, what is that 1/2 going to do to it? Well, it's inside the parentheses with x, so we know it's going to be horizontal. It's going to be multiplied, so it's going to be, or it is multiplied, so it's either going to be a stretch or a compression. So which one is this going to do? Well, what happens when you multiply by 1/2? When you multiply something by 1/2, it gets smaller, but remember when we're dealing with x, it always does the opposite. So multiplying by 1/2 would normally make something smaller, but with x it's going to make it bigger. So this is going to be a horizontal stretch by, and we could put a factor of, but remember now everything's always kind of the opposite. It does, it rebels, it is opposite. So it's not really by 1/2, it's going to be by its reciprocal 2. So that's what we're going to write there. And so what is this going to do to my table? Well, is there anything that's going to affect my y values? There's nothing that's not inside with x, so nothing's going to affect it. So I'm just going to go ahead and write y there. But that 1/2 does affect the x. How? It says 1/2 times x, but remember x always is the opposite, so we're not really multiplying by 1/2. What's the opposite of multiplying? We're dividing by 1/2. Now sometimes we don't like to divide with fractions, so remember multiplying by 1/2, dividing by 1/2 is the same as multiplying by its reciprocal, and the reciprocal of 1/2 would be 2/1, so really we're just going to multiply by 2. And that's why we wrote over there it's a horizontal stretch by 2, because really we end up multiplying them by 2. Alright, so first thing I'm going to do is, since my y's didn't change, I'm just going to bring them over. And then these x's here, we are going to bring them over, but we're going to multiply them by 2. So we got 2 times -2, 2 times -1, 2 times 0. Oops, these aren't lining up. Let me line them back up a little bit there. Alright, then we had 2 times 1, and we got 2 times 2. So now think about this. As we start to graph this, what is this graph going to look like? Well, it's a horizontal stretch, so I'm grabbing something on the left and the right side of it, and I'm pulling it apart. So if we're pulling it to the left and to the right, it should make it wider. So let's see. So -4, +4. Oops, let me go back to my pen there. Now I got to recount. -2, 1, 0, 0, 2, 1, and 4, 4. And so this is a parabola. Be careful because we've done a couple of the absolute values, so it's tempting to try to make a V out of it, but you can see your points don't lie in the shape of a V. Alright, and so there's our graph for that. If you wanted to see what the parent function looked like, to see that it did vertically stretch, we can plot those points real quick here. I'm just going to plot the points. And so you can see we actually did take those points and we pulled them horizontally out. We stretched it out. And so that's how you would do a horizontal stretch or horizontal compression.